There's no doubt that the James Webb Telescope is set to bring back tons of much anticipated data. Although it will take decades to fulfill its primary objectives, data is already trickling in. The James Webb Space Telescope, or JWST, is heavily invested in answering these questions. Number 1. What did the early universe look like? Number 2. When did the first stars and galaxies emerge? Number 3. How did the first galaxies evolve over time? Number 4. How and where do stars form? Number 5. What determines how many of them form and their individual masses? Number 6. How do stars die and how does their death impact the surrounding medium? Number 7. Where and how do planetary systems form and evolve? And finally, number 8. What can we learn about dark matter and dark energy? In this video, you'll learn about the James Webb Space Telescope's horrifying discovery about Hawking radiation, his out-of-this-world ideas about black holes, and the testing of one of Stephen Hawking's most controversial theories, new research suggests. On March 14th in 2018, Stephen Hawking passed away after a long and impactful career in physics. A lot of the late cosmologist's most impressive work addressed black holes, those insatiable disks of infinitely dense matter from which almost nothing can escape are fascinating cosmic vacuum cleaners that defy so many notions of physics, or what we think the universe should resemble. To understand these bizarre celestial objects, Hawking's work was critical, from the realization that black holes aren't truly black to the hair that may emanate from them. Hawking refined the data with his genius. Let's rewind the clock a few decades to the 1970s. It was then that Hawking proposed that dark matter, the invisible substance that makes up most matter in the cosmos, may actually be made of black holes formed in the earliest moments of the Big Bang. Now, 3 astronomers have developed a theory that explains not only the existence of dark matter, but also the appearance of the largest black holes in the universe akin to Hawking's findings. Study co-author Priyamvada Natarajan, an astrophysicist at Yale University, said in a statement, "What I find personally super exciting about this idea is how it elegantly unifies the 2 really challenging problems that I work on, that of probing the nature of dark matter and the formation and growth of black holes, and resolves them in one fell swoop. What's more, several new instruments, including the James Webb Space Telescope that just launched, could produce data needed to finally assess Hawking's famous notion." The James Webb Space Telescope was formerly known as the Next Generation Space Telescope, and scientists are certain it contains the instruments to effectively reap the results. The JWST observatory includes 3 main elements: the Integrated Science Instrument Module, ISIM, the Optical Telescope Element, OTE, and the Spacecraft Element, which comprises the spacecraft bus and the sunshield. Some of the key characteristics of the 6,200 kilogram JWST observatory are: Number 1. The primary mirror that is 6.5 meters in diameter and made of 18 mirror segments of gold-coated beryllium. Number 2. A giant shield protecting the telescope and the instruments from the light of the sun, which is about the size of a tennis court. Number 3. A wavelength range by the scientific instruments that cover infrared, mid-infrared, and ultraviolet light. And for number 4, the JWST will operate in an orbit around the L2 point, which is approximately 1.5 million kilometers away from Earth. This makes its operation, pointing and stability requirements much simpler in comparison to its predecessor, the Hubble Space Telescope. Scientists have discovered that dark matter does indeed make up over 80% of all the matter in the universe, yet it doesn't directly interact with light in any way. It just exists like a massive void, affecting the gravity within galaxies. Are black holes responsible for this elusive matter? It's certainly tempting to think so. After all, black holes are famously dark, so filling a galaxy with black holes could theoretically explain all the observations of dark matter. However, in the modern universe, black holes form only after massive stars die and collapse under the weight of their own gravity. So making black holes requires many stars. That means it requires epic amounts of normal matter. Scientists have been able to calculate where the first hydrogen and helium formed, so they know how much normal matter is in the universe. And when the numbers are added up, and after all the dark matter astronomers' observations, it's clear to see that there just simply isn't enough normal matter to justify all the black holes, let alone the dark matter that clearly exists. In 1971, Hawking suggested that black holes formed in the chaotic environment of the earliest moments of the Big Bang. He theorized that pockets of matter could spontaneously reach the densities needed to make black holes. In turn, this would flood the cosmos with black holes and their cousins, black matter, well before the first stars began to sparkle. Instead of following that lead, most astrophysicists focused on finding a new subatomic particle to justify dark matter. Hawking's colleagues noticed that the models of primordial black hole formation ran into observational issues. If too many formed in the early universe, they changed the picture of the leftover radiation from the early universe. That leftover radiation is commonly known as the cosmic microwave background, or CMB. This indicated that the theory only worked when the number and size of ancient black holes were fairly limited. Without that limit, measurements of CMB conflicted. But in 2015, when the Laser Interferometer Gravitational Wave Observatory found its first pair of colliding black holes, it became apparent that even black holes are cannibalistic. That surely might explain their large mass and prove Hawking's prediction. Black holes formed in the early universe, not in the hearts of dying stars. Natarajan, the Yale University professor of astronomy and physics, and Nico Capilouti at the University of Miami, and Gunther Hasinger at the European Space Agency, ESA, formed a task force in order to prove the theory of primordial black holes. In their experiments, the researchers assumed that the primordial black holes had a mass of around 1.4 times the mass of the Sun. They constructed a model of the universe that replaced all the dark matter with these fairly light black holes, and then they looked for observational clues that could validate the model or rule it out altogether. The team discovered that primordial black holes could definitely play a major role in the universe by seeding the first stars, the first galaxies, and the first supermassive black holes, which carry the acronym SMBHs, supermassive black holes. Observations indicate that stars, galaxies, and SMBHs appear very quickly in cosmological history. Natarajan was quoted saying, "Primordial black holes, if they do exist, could well be the seeds from which all supermassive black holes form, including the one at the center of the Milky Way, and the theory is simple and doesn't require a zoo of new particles to explain dark matter." Her colleague, Capilouti, included, "Our study shows that without introducing new particles or new physics, we can solve mysteries of modern cosmology from the nature of dark matter itself to the origin of supermassive black holes." Well, for now it's just an idea on a model, but it's about to be tested very soon with the help of the James Webb Space Telescope. It has been specifically designed to be the instrument of acquiring this knowledge. With its next-generation gravitational wave detectors and LISA, its Laser Interferometer Space Antenna, JWST is poised to reveal much more about black holes, including primordial ones if they exist. It's a joyful occasion. The JWST Observatory is on the brink of giving astronomers enough information to piece together the story of the first stars and, potentially, the origins of dark matter. Natarajan had to comment, "It was irresistible to explore this idea deeply, knowing it had the potential to be validated fairly soon." And to think, Stephen Hawking probably had it correct all along. He'll go down in history as one of the greatest scientists on Earth. So, scientists are definitely interested in some of his other far-out ideas about black holes and black matter. One unforgettable hypothesis is that black holes have hair. Scientists originally thought that black holes had no complicated details at their edges, so they were essentially bald. But in 2016, Hawking and Harvard University physicist Andrew Strominger suggested that black holes sport a luxurious crop of hair. This was a metaphor to say that long strands of zero-energy particles emanated from their event horizon. The next outlandish ideal of Hawking is that black holes may fizzle and explode. We mostly think of a black hole as a cosmic entity that sucks up everything, and nothing can escape its vacuum into the abyss. But in the 1970s, Hawking developed the concept of Hawking radiation, which would mean that instead of expanding over time, black holes might eventually dissolve. The idea suggests that matter and antimatter particles will suddenly emerge from nothing and then annihilate each other. And if that happens at the boundary of the black hole, it's possible for a particle to pop into existence on the outside edge of the black hole and zoom out into space, so its antimatter partner doesn't have a chance to annihilate it, and instead gets sucked into the black hole center. If this happens for a long duration, it means that the black hole is leaking, and therefore its size would decrease. It means that light could actually be leaking out of some massive black holes. So far, no one has directly measured Hawking radiation, but most physicists are convinced it exists. Do you agree with Hawking's predictions about black holes? Are Are they primordial? Do they have hair? And can they actually fizzle or deflate? Since knowledge is power and the science isn't settled, be sure to comment down below. For more extraordinary details about the mysteries of space, smack that like button, subscribe to Space Infinity, share this video, and head to the Space Infinity archive for unlimited power.